the null hypothesis states that there is no significant difference between the two population means. And then the second one, the alternative hypothesis, states that there is a significant difference between the two population means. As you may have noticed, our t statistic of 0.4159 is less than the critical t-value of 2.306. That is why we can also determine whether the mean difference is significant or not using confidence intervals. In this video, we will be conducting an independent samples t-test given the two sample datasets. The question goes, a researcher is investigating whether there is a significant difference in the average scores of two different teaching methods for a standardized test. The researcher randomly selects two groups of students. Group A is taught using method 1 and Group B is taught using method 2. After the teaching sessions, both groups take the same standardized test and their scores are recorded. The scores for each group are as follows. Group A, who was taught method 1, has scores 78, 85, 92, 79, and 88. While Group B, method 2, has scores 82, 88, 75, 90, and 79. Perform an independent samples t-test at a significance level alpha of 0.05 to determine if there is a significant difference in the average scores between the two teaching methods. Assume equal variances for the two groups. We proceed by opening the app. Click the menu over here. Search for independent samples and select the specified calculator. To answer the question, is dataset given? We select yes in the drop-down menu since we are given the two independent sample datasets. Next, we will input the given data. For Group A Method 1, we have 78, 85, 92, 79, and 88. And for Group B Method 2, we have 82, 88, 75, 90, and 79. For the significance level alpha, we are told that its value is 0.05. For the direction of the test, we were told to determine if there is a significant difference in average scores. It did not state whether sample 1 has a mean that is greater or lesser than the mean of sample 2. This gives us the hint that we are conducting a two-tailed test. So we leave this option as is. Lastly, we were told to assume equal variances. Now that we have finished filling the required values, we proceed by clicking the button and watching an ad to unlock the solution. When we are given the two sample datasets, the first thing that we need to do will be to calculate the sample sizes, the sample means, and the sample standard deviations. For the first dataset, we have its sample size, n1 is equal to 5, since there were 5 scores that were given. To calculate the sample mean x bar 1, we add all of the scores and then divide the total by n1, which give us 84.4. Next, we subtract the sample mean from each score in the dataset, square the resulting difference, and then add everything to get the sum of square deviations from the mean. Next, we calculate the variance by dividing the previous result by n1 minus 1, or 5 minus 1 equal to 4. Since the standard deviation is just the square root of the variance, we now have our sample standard deviation S1. We repeat the same process to determine the values for N2, X bar 2, and S2 in the second dataset. Now that we have the relevant descriptive statistics for samples 1 and 2, we now proceed with performing the independent samples t-test. Step 1, we formulate the hypothesis as shown below. So since we are conducting a two-tailed test, it follows that the alternative hypothesis will use the symbol is not equal to. So here is the symbol for the null hypothesis and the alternative hypothesis. So it states here, the null hypothesis states that there is no significant difference between the two population means. And then the second one, the alternative hypothesis, states that there is a significant difference between the two population means. In other words, there is a significant difference in the population mean scores of students who were subjected to different methods of teaching. For step 2, we calculate the degrees of freedom. In this particular part, we add the two sample sizes and then subtract by 2. So in this case, the degrees of freedom is 5 plus 5 minus 2 is equal to 8. In step 3, we determine the critical t-value. To do this, we proceed at the detailed t table. So we zoom into this particular table, and the first thing that we will do is to locate the degrees of freedom in the first column. So a while ago, we have calculated that it is equal to 8. So this is the degrees of freedom. And then, okay, since we are conducting a two-tailed test, we will locate the location of our significance level alpha, which is equal to 0.05. So the intersection of 0.05 and 8 in the table will be our critical t-value, which in this case is 2.306. That is why, if we go back to the solution, we have here our critical t-value equal to 2.306. For step 4, we formulate the decision rule. Since this is a two-tailed test, we have two critical values, negative 2.306 and positive 2.306. A t-statistic with a value lower than negative 2.306 and a value higher than positive 2.306 are considered significant. As such, we use the absolute value notation to make the decision rule brief and concise. As a result, whenever the absolute value of the t-statistic is greater than the critical t-value of 2.306, we reject the null hypothesis. Otherwise, we fail to reject it. Now for step 5, we calculate the test statistic using the given formula. And by substituting the values that we have calculated earlier, we have the following result. The t-statistic is equal to 0.4159. Now in step 6, we formulate the conclusion based on our decision rule. As you may have noticed, our t-statistic of 0.4159 is less than the critical t-value of 2.306. That is why the result of the test is not significant. We also included an optional part here where we conducted a p-value approach to test the significance of our result. So if the p-value is less than the significance level alpha, we reject the null hypothesis. Otherwise, we fail to reject it. In this case, since p is greater than the significance level alpha, we fail to reject the null hypothesis. Again, take note that this result is always the same as with the critical value approach that we have conducted in step 6. Another optional step, we can also determine whether the mean difference is significant or not using confidence intervals. The idea is that if 0 is found within the interval, then the mean difference is not statistically significant. As a result, since 0 is found within the 90% confidence interval, and then on the 95% confidence interval, and then on the 99% confidence interval, we conclude that the mean difference is not statistically significant. There's not enough evidence to claim that there is a real, meaningful difference between the scores of students who were subjected to two different methods of teaching. So lastly, for the effect size, we use the following formula and find that the observed difference between the groups is medium or moderate, since its value is between 0.2 and 0.5. This means that the difference between the two teaching methods, while not huge, is still substantial enough to be considered of moderate significance. And that concludes the solution to this question. If you find this video helpful, please leave it a thumbs up, subscribe to this channel if you are not yet subscribed, and ring the notification bell so that you will be updated on our latest uploads. And as always, I'll see you on the next one.